We've got all this amazing data on the blockchain, but how many people actually access it? Well, using Ape Framework, you can scrape historical data like we've done here with crvUSD and analyze it using all the robust tools Python has to offer. Let's dive in. For this video, we're going to be showing off how to create the Ape Framework script that produced this series of charts from live blockchain data. In this case, we are tracing the user journey of one particular crvUSD borrower. So the top graph shows the price of Bitcoin. This is a user that took a fairly YOLO risky position in WBTC. This was with 4 bands, if you're familiar with those. That's that shaded green line underneath the solid green line, which is actually the price of Bitcoin. So this is basically when Bitcoin is going from $30,000 and then dipping into like 20s and then all of a sudden shooting up to $45,000 in recent weeks. This band beneath it is the user constantly managing their position. This is a liquidation price. So right here, they start to get in trouble, start to get liquidated, but then thankfully the price of Bitcoin goes back up and they manage their position accordingly. And the second line, you can see their health factor throughout this entire journey. They got to keep it above 0. They actually get hard liquidated. But fortunately, Curve has the soft liquidation mechanisms that prevent you from actually dipping there. You can see in this window when the price of Bitcoin was dipping right in that person's liquidation range, their health got dramatically close to 0, but then shoots up and they're healthy here until they take out a new loan. And finally, in the bottom, you can see the composition of their collateral. So once you lend your WBTC to this market, it generally starts as WBTC, but when you get into trouble, when the price dips into your liquidation band, it quickly converts it into stablecoin. And as it exits, it converts back, which is what helps protect your position and maintain that loan health. So you can see this user sat in basically this situation for a long time before exiting. So it's pretty cool. And you'd probably like to be able to generate this for any particular crvUSD user, not just the kind of max riskiest ones. Let's walk through it. As always, we're going to refer you to the companion GitHub repository. In addition to show notes, a lot of helpful links, it's also got the unfinished and finished version of this script. So you'll be able to live code with us in this video, and when we're done, you'll be able to compare what you've written into here against the actual working version. And what's great is if you followed the first video in the series, you'll actually just be able to run this working version of the script and actually pull the live data for yourself. Or you could expand the script as you need. In this case, for example, we're only looking at one single highly degen user in one market, the WBTC market, but you could actually use on-chain data to pull a full list of all markets and iterate over those, pull a list of all the users who have loans, and see everybody's position and compare them. So it's pretty fun, good building block. We, of course, can't live code all 200 lines of code, so we're going to walk through the code briefly and what it does so you have some familiarity. And where there's actual ape concepts you can see highlighted with some of these XXXs here to be filled in, we're going to complete it and instruct you on kind of the changes between ape and brownie and how ape would work with this. Lines 5 through 7, you'll note that we're importing some basic Python data science libraries. This is one of the powers of Ape Framework, which is that Python is really good for data science, and Ape can actually be that glue layer that pulls all the live blockchain data and allows you to run, in this case, some pretty simplistic charts, but you could go wild with this. Python has got a bunch of great 3D plotting animation libraries, so you can get really imaginative using this as the glue layer. We also have a test mode versus production mode. The big difference there is the resolution. Instead of just taking 20 snapshots between your start and your end block, if you flip this to production, it's going to take 1,000 or 10,000 or however many you really want. Other than that, pretty self-explanatory. On line 24 and line 25, we're pulling in the ape contract functionality. The ape contract functionality is because our ape config is set to actually pull the contracts from Etherscan. We don't need to deal with ABIs. It's going to read the controller address, and from this controller, it's going to pull in the companion AMM contract, which we'll see a bit later how it works. We want to start by showing off line 35 here. We are giving this bounds of which block to scrape between. So we scrape between the start block, which we've hard-coded, and we picked a number that's pretty close to when this starts, so we have a nice coverage of data, and the end block. You could actually do like much wider bounds, and it won't actually cause too many issues. The thing I wanted to show off, this was a bit confusing for me coming from Brownie, is ordinarily the way you'd run this script is you just type ape run and then the script name. In this case, it's crvUSD health. What it's doing is it's looking through the scripts directory and looking for a file name, crvUSD health. And it's not going to work. And the reason for this, it says, is because there's no such command crvUSD health. And this confused me. I had spent a lot of time trying to look, am I in the right directory? Did I accidentally delete it? But it turns out there's actually a feature, not a bug. What ape is doing is it's looking through the scripts directory and looking to see what actually compiles as valid Python. So for example, if I type Python and point directly to crvUSD health.py, it's going to complain an invalid syntax error. Invalid syntax error means it doesn't compile. But instead of giving me a syntax error, it just says, we tried to compile it, it doesn't exist. If we set a proper end block equals 0, which is kind of a silly concept because it's going to scrape basically backwards from here. But still, now it's valid Python. So if I try and run the Python of this, it doesn't have the ape framework, there's no provider. But now if I run, for example, ape run -- help, you will see that it's got both crvUSD health and crvUSD health final. When it's invalid Python, it's not going to be able to find it. So here crvUSD health disappears and it's showing up as some of these error messages. But pop a working block in there and it's going to run just fine. So this is actually, again, a feature, not a bug of ape. It's only giving you valid blocks or valid scripts. Problem, though, is that we are setting the end block as 0, so it's not giving us any data when it scrapes. Let's go ahead and fix that up. Instead of end block 0, we'd like to set this to the current chain height, so every time you run the script, it's going to give you updated. So instead of hard coding it, we're going to use the built-in chain property within ape. And as you can see from this Snake Charmers article on the Ethereum website, the chain manager object within ape is really robust. It's going to look for whatever chain it's currently connected to, and you can get all sorts of nitty-gritty data. So for example, this chain.blocks.head will read information, in this case, the Genesis block. We're going to get the height of this using chain.blocks.height. And if we plug that in there, then this is going to be setting this properly. As you can see from here, it runs through the main loop. And just like with Brownie, it's looking for a function named main, and it's going to execute whatever's in that. This is going to point to the process user data function, which we'll look at in just a second. While we're here, though, if you notice when we ran before, we got these unsightly error messages. And these error messages aren't critical. They're just saying that the block is out of range. Basically, we set a start and an end block to a point where this user didn't actually have a loan, and it was getting back some invalid blocks, which is fine. We want to get rid of that. Fortunately, ape plays nicely with the kind of default Python logging module, which we imported in line 1. In particular, we are going to import from ape.logging, their logging submodule. We're going to pull in their logger function. And on line 22 here, we will set this as only showing us critical messages. So other than this, the script is mostly Python, so we won't walk through it in too much detail. Basically, the main loop in the main function is pulling data from this process user data where we pass the address we'd like to pull for, start block, end block resolution. You just loop over this if you want to pull multiple users. Process user data is going to be kind of setting and munging the data properly. So nothing too interesting here except that it goes into this process block, which is the only place of this that is not Pythonic, what lies on ape. Process block is like Brownie. It's trying to pull up block identifier, which allows us to scrape through historical data. So basically, we're just taking a snapshot over the resolution number of windows. The controller.health is giving us the user's health at any given block. The AMM was the companion contract to that particular controller where it's storing the user's tick numbers. For this user, they were 4 ticks, which is extremely degenerate. The safest you could be would be 50 ticks, which would make that band much, much wider. The AMM price is the price of Bitcoin, and the user state is the percentage that the user is within stables. Other than that, the rest of it is just plotting and saving the data. So we'll look through that briefly as we run our final version and see what this produces. You'll notice this is running a bit slower because it's actually like pulling valid data and having to run a bit more through this instead of getting caught up in this try except block that goes a little quicker. Still, because we're doing such a narrow slice, it's running a lot quicker. So we're already about halfway done with this, and it's going to run in about 10 more seconds. So other than that, you can see the plotting code. This is, of course, in the GitHub. You can see the saved data file, which is really important when you're scraping because if it takes 20 minutes, you want to have it. And you can see that our final chart looks very similar to the chart that we showed at the beginning of the video. It's not quite as finely grained. So the user actually did get liquidated a little bit here. The user got liquidated significantly here, which it did have enough resolution to pick up. And you can see the user's health moving pretty accordingly as they readjust their positions. So you can have a lot of fun with this. If you got any questions, feel free to drop them in the comments. This is going to be very useful for you in your data analysis pursuits, and we hope that Ape becomes an invaluable tool for you. Stay safe out there, friends.